Hey everybody, in this video we're going to talk a little bit about system services in an x86-64 machine while programming in assembly. This video is going to focus on YASM assembly, but this should also work for any other assembly language that you program, as long as you have the right kind of CPU. x86-64 is also known as AMD 64 architecture, so bear that in mind. Okay, so for starters, let's see. Here's a wonderful book. I love pushing this book. I did not write it. The person who wrote it is a genius. It's called x86-64 Assembly Language Programming with Ubuntu. It's a free and open source book, so anybody can go get it. Find his website, and here's the version I'm using. And honestly, a really old version of this book is still really good. He just keeps, making little improvements. But it was good even a long time ago. Anyway, so what is a system service? For starters, before I go into this book a little bit more, what is a system service? Suppose, for the sake of argument, that I've already written an assembly program, a pure assembly program, not a hybrid module program or anything. If you want to learn assembly, see my other videos, but for now I'm just going to assume you kind of already know how, so I'm just going to open up a pre-made program here. I'm going to do nano so I can edit the assembly file, just so you can see what's inside of here. Okay, so I hope the red is not too hard to see. Oh, the tabs got ruined on Nano. Hang on, let me see if I can just open this up in Genie. Should have done that to begin with. Okay. Yeah, okay, I wrote it in Genie, and I guess I don't have the tabs set up in Nano very well. Okay, so, here's like my assembly program. I just have a little string here, and a string length, and CRLF for like a line feed, and some file descriptors, and stuff that I talk about in other videos. Here's the entry point of the program, just like a little start entry point because it's pure assembly. And all I'm going to do is I'm going to print a message, right? I'm just going to print a little hello message and then call on CRLF. All CRLF does is it just prints a new line. So the program is really, really simple. If I run it right now, you'll just see what happens. If I say, let's see, clear and make run. Then you can see there's some stuff happening up here in the makefile, which I forgot to update the title. Ignore that. Basically, the real action is this line right here. Hello, I'm printing using a system service. If you already know assembly, then you have probably already seen this before and it seems a little boring. That's good. But I just want you to know that we're using a system service to actually do the printing. Kind of take it for granted here, this little instruction called Syscall. What is a Syscall? Well, it's just basically you set up some variables, some codes, some data, whatever, in some special registers. One of the registers lets the system know what you want it to do. One of the registers is like, or I guess all the following registers, if they're needed, are just input to the system call that you're trying to do. So in this case, RAX is letting the system know, I want you to do this code. I want you to do this certain thing. I have a define set up here called system right, but if you look up in my little defines area, it's just a number 1. So that means if I set the number 1 in RAX, I'm letting the system know that I want it to write to some pipe, to some file. Then, depending on what code you're using, RDI, RSI, RDX, and other things may be needed or may not be needed at all. In this case, when I'm writing somewhere, it wants 3 arguments, so I have to use RDI, RSI, and RDX, because those are the 3 arguments. The first argument that it wants is where to print. See my other videos for a more in-depth explanation of file descriptors and pipes, but just long story short, every program that gets created ends up with 3 pipes, standard input, standard output, and standard error. Standard out is pipe number 1. Let's see, where's that? Yeah, it's just assigned a number 1. So every program has its own number 1 pipe, which is just standard output. And I guess I should say that it gets piped to file descriptor 1. It's kind of like an ambiguous term, sort of, but the system write call will write data to a file. And if I give it a file handle of just 1, that lets the system know, oh, actually, I want to write to this standard output for the one particular process that we're inside of. But you could open any file that you want and get like a file handle to it, and the operating system will realize, oh, I associate that file handle I gave you with this certain open file that you created or opened for reading or whatever. And so when you give the handle back, it knows where to write. So in this case, it's treating the standard output just like a file with a special handle of just one. I'll talk about that more in another video. Then the next two arguments it wants is just a pointer to the first character of the message that you want to print, and then just an integer representing the length of the message that you want to print. And if we just look up here again at my little hello, my hello symbol points to an array of bytes, just characters. There is no null terminator on there. It's just bytes only. And so when I give it, message hello by itself, what I'm really giving it is a pointer to that H letter, just a pointer to the memory location, I'm pointing to the memory location of the very first character in that string. And then for the length, I'm just using a special token little shortcut thing where you just put a $ minus and then the name of another string, and then the assembler will compute the length of that string. So this right here is the same thing as me just typing the exact length of the string. I don't even know what it is. I don't feel like counting it. You can at home if you want. 1, 2, 3, 4. I'm not going to do it. Anyway, so we basically just say, I would like to write somewhere. I would like to write to the standard output file handle. I would like to, to that pipe. I would like to write, this string, and then I would like to tell you that this is how long that string is. And then after you set all that stuff up, you just say system call. And the system will go ahead and do all of the hard work for you. It'll go figure out how to actually write data to the file and, figure out how to do everything that it's supposed to do. And all you have to do is a little system call here. Right after this, you can see that I have a call CRLF. That's just a function call. I talked about functions in other videos, but basically, I'm just calling a function here. And it does the same thing. It makes a system call, but instead of printing the hello string, it's printing my CRLF string. And if you just kind of look at what my CRLF is, it's just these two characters, 13 and 10. So like, /r/n for carriage return line feed. That's why I call it CRLF. So all this program does is just print a message and then a new line. And then at the very end, it does another system call to properly exit the program. If this was a hybrid program and I had like the entry point of main, that the GCC libraries give you, then I would probably just want to return at the end of this function. But since this is pure assembly, I can actually just exit the program and be fine. So exit with success is a different system call code. Notice how I have the symbol system exit loaded into RAX. And if you look up here, system exit is just the code 60. So if I send a code of 1 into RAX, that means I want to write some data somewhere. If I send a code of 60 somewhere, that means I want to exit the program. The only argument that takes is RDI, which is just what is the exit code that you want to return to the operating system. So if you recall from some of my other videos, let's see, if we do echo hello, echo always succeeds, at least as far as I know. It's like really hard to make it fail. If I echo hello, then the program echo launches and it will succeed by just printing the word hello. Like, see how it just does that? So that means after that command, I could echo the special variable $? just to see what the echo command exited with, right? It should be a 0 because it succeeded. So you can see now a 0 under the hello. On the other hand, if I concatenate, let's say a file that exists, I should also get, an error code that is a 0, see how, or an exit code. See how it's a 0 at the very end. But if I try to concatenate a file that doesn't actually exist, I'll put OS release 2 because that doesn't exist. Notice how the cat command fails because it couldn't find the file, and the exit code is a 1. So all you're doing when setting RDI here is just controlling what exit code you want your program to exit with. This isn't very convenient for a human running a program. Maybe if you want to look at the exit code for some reason, but this is really, really convenient for programs that want to automate other programs. Just keep in mind, if you have a program that is executing another program and it wants to see if that program succeeded, the exit code is one of the easiest ways to find out if the program succeeded. So this is the whole idea of this entire program. We're just using two system calls to print something and then to exit the program. Hopefully this makes sense. And now I want to go show you this wonderful, wonderful book. If I didn't already say this before, sorry if I already did. This book is written by a genius. It's called This. Here's the guy who wrote the book. And Here's the version that I'm using, but old versions are good. You can get this book for free on his website if you go find it. So I'm just going to go to this assembly book, which deals with a lot of YASM assembly tips and tricks and tutorials and explanations and things. And I'm going to go to the section labeled after System Services. So for me, this is Chapter 13, System Services, just to give you a little explanation of what this is. This is basically what I said. It gives you, a chance for your application to ask the operating system to do something for you that you don't want to program from scratch in assembly or that you can't program. But here's the real juicy details here. If we go to, okay. If we go to the appendix, which is Appendix C, which is section 23.0, System Services, there's a whole bunch of system services in here that you can read about. So for starters, if we go down a little bit, notice how it says Basic System Services. If we go down a little bit, you can see right here the system write service that we've been using in the sample assembly program. When we're just printing, we say code 1 is to write something, and so this is what the table says. It says here's the call code which you place inside of RAX before Syscall. Call code 1 is going to be to write characters, and then it tells you what arguments it needs. So like RDI is the file descriptor. Where do you want to write to? Just like I said before, you could give it a file handle that you already received from opening a file or creating a file. Or you could give it 0 or 1 or 2 if you want to try to write to one of the pipes, although actually file descriptor 0 is standard input. I don't think that would actually work. You could give file descriptor 0 to reading if you wanted to read the user's input, or any input that program was given through its standard input. RSI is just the address of the characters to write, like we talked about before, and then RDX is the count of the characters to write. Notice how there are no more arguments, and that's why I only gave it 3 arguments besides RAX. Notice how it says here, if unsuccessful, it returns a negative value. If successful, it returns the count of characters actually written. This is a really, really good idea. If you think about it, a lot of new programmers, they don't really look at return codes when they call system services or built-in C functions or built-in C++ functions. They just kind of call it and hope for the best. But imagine if you tried to write a huge long string in using system write, call code 1, and maybe some of the characters did write, but the system decided to only write, I don't know, half for whatever reason. Maybe it ran out of buffer, maybe it interrupted your write or something like that. So it could happen. What that would mean is that the return value, it would be greater than 0, indicating that some characters were written, but it'll tell you exactly how many characters were written, so you'll know that you got to keep calling the syscall until all the characters were successfully written. Why would you do this? I don't know. Maybe you have a gigantic string, like maybe a full huge file, like a several gigabyte file, and you wanted to copy it to another file. So you'll be calling system write over and over again, and system write, it's only going to write so many bytes at the same time. So you use the return value to figure out how far forward in the read buffer you need to advance, or whatever, so that you can write the entire complete file or the entire complete string or whatever it is without any gaps, without it being truncated and so forth. And then of course, if it returns a negative value, then it totally failed. Like you tried to write to a bad file handle, like standard input, or a file handle that was closed, or a file handle that was open for reading only, something like that. And then you can use some if-else, branching logic. I mean, not if-else in assembly, it's just going to be comparison and then conditional jumping or branching. But you can have more control over your program, right? Because you want your program to be able to respond to errors. Let me just quickly cruise through all of the other options and let you know that in another video, I'm going to do a full tutorial for how to copy one file to another by opening one file for reading, and then like using system calls to read from it, and then open another file for writing, and then use system calls to write to it. And I'm going to do that looping buffer stuff that I talked about before. Anyway, but for now, I'm just going to go through the rest of these system call codes. Let's see. So first off, we got open. Well, if you want to open a file, then you just give it call code 2, and you pass in the address here, RDI. You say, here's the address of a null terminated file name. So that means somewhere in memory, you have to have the file name that you want to open with a null terminator, like a 0 at the end of the string, either the full path or a relative path to wherever the program is currently running. And then RSI is going to be file status flags. And what does that mean? We can actually just search for that. I'm going to say Control C to copy, and then I'm going to do Control F to search for that. And let's see, what page am I on right now? 340. If I go down to the search results for that, it just explains what the file modes are. So if you put value 0, that means read only. You're opening the file in read only mode. Value 1, that means write only. Value 2 allows reading and writing to the file. So if you don't know what that means, well, there it was. What was I just on before? 40? Oh gosh, completely lost my, oh yeah, 40. Okay, so opening, pretty easy, right? Like if you didn't know this before, you didn't necessarily read me. You could just look at this table and go, what do I want to do? I want to open. So here's the code, here's the address that it needs. When you're done opening a file, when you're done working with a file, you want to close that file. Unless the whole program is going to terminate at that point. Maybe you have a function that gets called somewhat often, and you kind of always have to open a file and sort of look at something or write something. And maybe you want to close it when the function is over, right? You don't want to have a file handle just open forever. That's a waste of memory. And it might introduce bad behavior to your program if you just have a bunch of file handles floating around that you forgot about. So it's proper to close a file when you're finished with it. That's just going to be code 3, and it only wants one argument. It just wants the file descriptor of the file that you wanted to close. So if you open a file for reading or to create it, you get a file descriptor back. You should probably hang on to it somewhere on the stack, or like in a global variable, or like, in a register or whatever. Then when you're done doing something to that file and you're sure that it's time to close it, just give that handle right back when you call code 3 to close it. Then you can sort of like seek, forward and backwards through the file if you want to. You can fork the current process. That's kind of advanced for this video. You can exit. Remember before we exited from that program with code 60? So that's it. Call code 60. If you didn't watch this video, you could have gone through this table and just said, oh, if I want to terminate the executing process, I do a system call with code 60. And I'll give the exit status to RDI, which is typically 0 for success. Bunch of other stuffs, create, get the time of day, and then the file modes that we talked about before. And then file permissions. Let's see, where's the permission? I think it's when you want to create a file. Yeah, right here. If we wanted to create a file, that's code 85. RDI is the name of the file, like a pointer to the string. RSI is the file mode flags. And then you're thinking like, what are the file mode flags? Just go down here. And here you go. All the file modes that you could ever want. You just look at it and go, well, I guess I can just copy paste this number right here, and it'll end up being, whatever is described on the left and the right, like the group has read, write, and execute permissions, and so forth. Really, if you look at this long enough, you'll kind of realize that this is a quad word because it has a Q on the end of it, and the rest is just an octal file permissions notation, where this first number here, notice how the first two are zeros, but this first actual number here is something that applies to the user, and then the next one applies to the group. The next one applies to others who are not part of the user or group. And this video is not about file permissions. I'll probably make one later if I think people will actually watch it. But yeah, you can just kind of like look it up here if you want to and just copy paste that into a define somewhere. Let's see, what else? I just want to show you a little code snip just to illustrate a little bit more what I was talking about before. People usually make this mistake. They'll do, let's see, this is what people will usually do, like new programmers. Suppose this is a function, pretend we're in C or C++ for the time being. You call some sort of a system function or an API of some other library, and you just hope that it works. You just call it, and then your program continues underneath, right? It's a bad idea because maybe that failed. Maybe there's some action you need to take. So instead, it's a really good idea to check the return result. Or I should say, an even better idea is check the documentation. Usually these types of, C system calls or function calls or API calls or whatever, they'll return something indicating success or failure. Sometimes the documentation will tell you, oh, you've got to put like a pointer to some other data structure in the arguments, and then the result comes there. Of course, just read the documentation, but usually it's just, it returns some sort of a result. So you want to grab the result and then check the result. In this case, I'm assuming this is sort of a standard function that will return 0 or greater on success, like the system write call or the system read call, and return less than 0 if it fails. So here I'm just responding. You know, if it's like, if the result was greater than or 0, then it's like, yay, we can proceed. Maybe I'll continue with my program in some way. And if it's not, then I'll print a complaint to the user, and then I'll take some sort of an action, like I'll write to a log file, send an email somewhere, you know, do something to try and recover from the error and alert admins to the error. And in this case, I'm just throwing an exception. This video is not about exceptions, but so I just want you to know this is a good design pattern to not just discard the result of a call to something. You should check the result and see what you're supposed to do. Let's see, what else did I want to tell you? System services, file handles. Yeah, okay, I think that's everything that I wanted to tell you. In future videos, I'm going to talk about, you know, some of this stuff much more in depth, like with my file IO video that I'm going to publish pretty soon, which is, you know, it lets you read and write to files, and it uses a loop to read a little bit at a time. Okay, thank you so much for watching this video. I hope you learned a little bit of stuff and had a little bit of fun. I'm outie, or something. Goodbye. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.